Welcome everyone to today's Global R&D. For those of you that don't know me, I'm Dimitris. I'll be your host for today. Some more people are trickling in, but maybe we can get started and, hopefully the rest will join. So today we have a very nice agenda for you all. We'll start with some developer experience updates, then go over a few features, Motoko 1.0, important one, no neuron transparency, and then some demos, hopefully very interesting, and also some long-awaited features like Canister Migration and the Sui Wallet on ICP. And then we'll conclude with a community demo. So without further ado, let's jump straight in. So Raymond, over to you with ICP CLI.
Thanks, Dimitris. Hello, everybody. So I've talked about the ICP CLI a few times already. You can go to the next slide, please. So, but to recap, we're making a new command line tool for developers to build and deploy their apps and to interact with the network. The idea is to deprecate some of the features from GFX without disrupting current developers too much, make the experience better, and have a better decoupling between the command line tool and the underlying tools that you build to that you use to build your apps. Next slide. So we're just about ready to do like a preview release. So we're planning to open source a repository soon. Some of the features that are going to be available is that you're going to be able to publish your own recipes. So this is what you use to build and like the instructions to build and deploy. You'll be able to build Motoko, Rust, and asset canisters off the bat, deploy them to a local test network or to mainnet. And you also use this new feature of canister environment variables so that you can build once and deploy multiple times. So, of course, this is a preview release, and so there's a few caveats. For now, we only support plain text identities, and we also don't have an installer. So we're really looking to get some feedback and make sure that we we have manifests defined correctly, and we might make some adjustments before we make like a first release. Next slide, please. So we're going to be open sourcing the repository on October 31st, and we hope that you give it a try. We'll, of course, put an announcement in the forum and on the Discord channel, and I've added a link here to the Discord channel. We're looking forward to engage with you and hear your feedback directly. And that's it.
All right. Thanks, Raymond. Let's go to features now. And first we have Motoko 1.0. I don't know if it's Claudio or Christoph who's starting, but feel free to take it away.
Hey, Dimitris, thanks. It's Christoph starting. So hi, everyone. I'm Christoph from the languages team, and I'm working on Motoko. And we've recently made some great strides in improving the language and have accumulated a set of new features that we'd like to call 1.0 at some point. Today, we're giving you a bit of a sneak peek of what that is. Next slide, please. So obviously, Motoko has been in the close vicinity of what Caffeine's doing, and so a lot of these features have been inspired or been requested by the AI folks. But as a Motoko user myself, I can say that this is also very much in the interest of the human Motoko developer. Next slide, please. Right, so I said there was 3 major features. Today we'll be showing you the extended dot notation implicit arguments, which play very nicely together. And the third one is mixins, which I'll probably be talking about at some future Global R&D. The primary reason for the two features we'll be showing today is that it makes the code a lot more concise, familiar to folks coming from OO languages, improves legibility, and we've noticed a serious uptick in AI performance of these of code written using these features. And the how is that we have functions that can now declare a self parameter, very similar to what you might know from Rust or the this in object-oriented languages. And we have implicit parameters, and we'll show a bit. Let's see what that looks like when you use them on the next slide. Thank you very much. So this is some code, some code we updated doing this basically on the, and you see that things get a lot more concise and a lot less noisy, and well, just more familiar, I guess. So next slide, please. So yeah, don't too long didn't watch Global R&D. We start out with a map add as you would have written it. Or would write it today with Motoko, and you see that it's quite verbose. And then there's two steps to improve it here. One is the dot notation makes this so the first parameter moves out, and then using implicits we can even infer the net compare here. As before, you need imports for map and net, but if you don't have them and try to write code, then you get import suggestions from your available packages. So that's quite nice. Next slide, please. So I'll start out talking about the extended dot notation. Motoko encourages static functions over methods, and that is primarily because if you separate the data from operations, it's a lot easier to do orthogonal persistence. But that means that you kind of write in this functional style, which has a well-known UX disadvantage, where you can see here it's kind of like inside out, right? The array, the initial piece of data is right there in the middle, and then you kind of have to read your way out. But users, and as we found out, AI also expect this object-oriented notation, which lets you kind of write left to right, and reads a lot more fluent. And it also enables dot completion in the IDE. Next slide, please. So the way we do this is that it's very easy. You basically now, if you name the first parameter in your function self, it is now available for this extended dot notation. So you can either write map.entries in the new style, or you can call the function as previously where you use the functional style. Next slide, please. And here's where Claudia is going to take over and talk about implicits.
Hello. Well done, Christoph. So the second part is implicit arguments. So Motoko has this preference for static functions over methods that you get from OO languages. And sometimes this can lead to boilerplate code. So especially when you use collections like map or set, the way we designed the API for the core language, for the new core package, is that every operation has to take an explicit comparison function, because these sets or maps are ordered and they're using red boxes. Now, it would be much nicer if you didn't have to pass these auxiliary functions with every operation leading to the code below. That's what we'd like to be able to write. An implicit arguments let you do this. Next slide, please. So the way you opt into implicit arguments is that you just, when you declare your method, you can decorate the type of individual argument as an implicit argument. And then the compiler at call sites will try to supply suitable candidate arguments for those parameters. So to enable implicit arguments, you just declare the parameter implicit, and then at the call site, you can call this very succinctly map.add kv to add a key value pair to a map without having to pass the comparison function. That's the shortest style, using the self syntax as well. Otherwise, if you want to specify a specific comparison function, you can still be explicit and pass it in. And so you get this, every operation has two signatures, one without any implicit arguments and one with its implicit arguments passed explicitly. And then, of course, the old style is still variable, so you can write out everything in full gory detail. And the nice part about this is that we won't break anybody's code. So things will continue to compile without you having to change anything, even though this feature is here. Next slide, please. So this looks like it's just syntactic sugar, but it's not actually, because a compiler needs to use a typing context to infer for dot notation which static method you want to call in which library. So it's filling in the library that you want to call. And for implicit arguments, it has to figure out, well, which argument to fill in for the value. And it again does this using a type-based resolution process. Now, sometimes there might be several ways to resolve these syntactic features, right? And in general, the compiler will choose the most specific one that makes sense. But if there isn't a most specific one, instead of just choosing an arbitrary one and leaving you to guess what happens when the code does something different from what you expect, it'll report an ambiguity. And because we still have the old syntax available, you can always resolve any ambiguity using the explicit syntax. Now, so far, we found that this rarely is necessary, but it does happen. So the ideas here are similar to the way we do type argument inference, right? Except what we're inferring is not type arguments, but values. We pass the call size. Next slide, please. So another nice side effect of like the dot notation of these self parameters is that it lets you lets third parties extend the functionality that we've provided. Okay, so maybe you don't like using our iterator library, something's missing. Maybe you're missing MapReduce. Well, with the self parameters, you can actually import another library that you've written or that a third party has written that declares a MapReduce function, and then you can just call it using the dot notation as if it were a member on the original iter class that we provided. So that's kind of nice. Next slide. So, in summary, so what are the benefits? Well, the code should be easier to write now and easier to read because it's shorter and because it reads left to right, and much easier to maintain. Dollar calls and implicits are resolved at compile time. That means we get the kind of syntax of the dynamic dispatch that you're familiar with from OO, but with the performance of static dispatch. Separating the data from operations is kind of key to keeping Motoko's upgrade simple. So we've kept that style of code, even though we've given you something that appears to be like dot notation. For example, one major advantage of this is that adding a method to an API, which is a fairly frequent operation, is going to be a non-breaking change. And we've designed these features not for AI, but for our users. But we hope it's good for AI too. Of course, there's some drawbacks, right? Now there's several ways to call a function. You can use the old style, you can use self, you can be explicit about the arguments, you can be implicit about some of the arguments. And, you know, that gives you more freedom, but I think freedom is actually a good thing, right? It does also open up the possibility for more debate in, bike shedding style code reviews. So the way we've done this, libraries do have to do some work to enable the syntax, right? They have to declare the self parameters and they have to declare the implicit arguments. But none of these changes will break existing clients, even if they don't opt through syntax. So it's a nice gradual change that people can make. Also, the syntax here, I mean, we're pretty close to releasing it, but some details may still change. I think that's the last slide. Is that the last slide? Yep. All right. Thank you very much.
All right. Thank you both. Exciting to see these features. And I'm really glad that I don't have to type this compare function personally. So very glad to see that. All right. Then moving on to known neuron transparency. Jason, tell us all about it.
Hi, Rod. I'm Jason from the governance team, and I'm excited to present the recent changes in the NNS involving the known neurons. First, let me provide some background on what are the known neurons. In the NNS, a neuron can follow another neuron on certain topics, and when the followee votes on the proposals of this topic, the follower also votes. In other words, the follower is delegating their voting power to the followee. The known neurons are a curated list of neurons which can be added through NNS proposals. If you use the NNS tab, you might have seen the follow menu like the one on the right, which shows the known neurons as options for following. This also gives a new user a place to start for configuring their neuron following setting. Next slide, please. In order to help neuron owners make more informed decisions regarding which neurons to follow, we introduced some new features recently. First, we're completing the life cycle of the known neurons. Previously, they can only be added, but now they can be updated or deleted too through NNS proposals. We also added new information such as a list of links and committed topics so that potential followers can find out more information about those known neurons. The committed topics are a way for the known neurons to declare that they are experts on certain topics or committed to become one. Since there are so many types of proposals and it's hard for anyone to be able to carefully review all of them. Also, from the perspective of the individual neuron owners, it's important for them to follow known neurons on topics they're committed to always vote on so that they wouldn't miss out on voting rewards. Finally, the voting history of the known neurons are also permanently recorded on-chain in the NLS governance. In order to achieve those, we introduced a new proposal type to deregister a known neuron given its ID, extended existing registered known neuron proposal type to allow updates and added new fields, recorded known neuron voting history at the time of voting, as well as the time of reward distribution when we know for sure that the neuron abstains on the proposals. And we also added a voting history API so that anyone can query it. Next slide, please. Since the features were enabled in October the 13th, the deregistered known neuron proposal type is already used for 2 proposals, and the registered known neuron proposal type is already used for updating 3 known neurons. In all of those 3 updates, we are seeing home pages and the open chat profile page added as links. In 2 of those proposals, the committed topics were also added. Next slide, please. Now, let's talk a little bit about the known neuron voting history. The new API list neuron votes will return votes of a given neuron ID of a known neuron. It's paginated with 500 votes per request, and the vote abstentions are also recorded and exposed in addition to the yes and no votes. Note that if a known neuron is newly created and not eligible to vote on a proposal, it doesn't count as abstention. Now, anyone can query this API to learn about the votes of any known neuron. As of October the 27th, when I collected the data myself, votes of 155 proposals were recorded for the 54 known neurons. 31 of them, which is more than half, are voted on every proposal. 7 of them voted on more than 90%, but not all of the proposals. 3 neurons voted between like 1 to 12% of the proposals, and 13 of them didn't vote at all. One thing I'd like to note is that although it looks like a lot of known neurons are inactive, it's just 2 weeks of data, and some of the topics haven't had any proposals under them yet, which means it's still possible that certain known neurons are committed to voting on the topics. They just happen to not have any proposals on them yet. Next slide, please. Finally, I just wanted to mention that the current work is mostly on NS governance, and any front-end can use those new features to display more information about the known neurons. In the future, we'll also work on the client side. For example, we already have plans to display the links and the committed topics on the NNS tab. In the future, we'll also work on displaying the voting stats of the known neurons. That's it from me. Thanks, and back to you, Dimitris.
All right. Thank you, Jason. There is a question in the chat. Does list neuron votes only work for known neurons, or does it work for all public neurons? Maybe you can quickly answer that.
Yeah. So it only works for the known neurons for now. it is named this way because then in the future it can be extended to getting votes of all the other neurons.
All right. Thank you very much. And with that, we can move on to demos. And the first one will be about canister migration. So I'll stop sharing now. And Stefan, you can take over the screen and tell us all about canister migration.
Yeah, hello everybody. So I'm going to take over the screen since this is going to be a demo, not just slides. So I wanted to demo canister migrations. So as most of you might know, is if you deploy a canister to the internet computer, you're actually deploying it to one of its subnets. And canister migration is simply the idea that you should be able to take a canister that is on one subnet and migrate it to live on a different subnet. And the idea here is that this is something that the controller of the canister can just do on their own. So it's not like NNS voting or anything like that. A controller of a canister should just be able to move a canister from A to B. And there are a few reasons why you might want to do that. Probably the biggest one is if your canister shares the subnet with some very busy canister. Let's say there is a caffeine dApp that really took off and now the load balancing is kind of off and our canister is suffering from the success of that other canister. At this point, we might want to take our canister and migrate it away. Or other reasons why you might want to do that is maybe you want to be on the fiduciary subnet or the Swiss subnet or the European subnet or whatever. It could also be that you have multiple canisters and you want to make sure all of your canisters are on the same subnet so that they can talk to each other more efficiently. Or maybe you want to do the exact opposite. You have multiple canisters and you want them on different subnets so that they don't compete with each other for capacity. So how did we get to a point where we have canister migrations? We implemented a new NNS canister that implements that functionality, and it actually required quite a few more enhancements to the core protocol to make it work. That's because canisters and where they are exactly is such a fundamental part of the Internet Computer Protocol that if you change anything there, it touches a lot of things. Oh. Okay, so the idea behind the canister migration or end-to-end migration is quite simple, right? You have a canister that is on subnet A, and by the end of it, you would like to have that canister on subnet B. And you want to preserve everything about this canister. You want it to have the same state as before, the same code as before, and crucially, you want it to have the same canister ID as before. And now, before the canister migration feature, you could almost get there, but not quite. What you could already do before is you could clone a canister. Like you could always create a new canister on the right subnet. And then what you can also do is you can move the state and the code over. This recently got a lot easier to do with the snapshot upload and download feature. So, which is available since last month. So what you can do now is you can take a snapshot of the old canister, download that snapshot, re-upload that snapshot to your new canister, and now you have cloned the code. However, this only gets you to like the picture below. You now have a clone on the right subnet, but this canister still has a completely different canister ID. And the part that is missing and the part that is now new is a command to get this last step the way there. So we're introducing a new DFX command called migrate ID. So you tell it to migrate the ID from one canister to the other. And after you do that, the way it will look like is the new canister will now have the name that the old canister had. And the old canister was deleted because, of course, you can't have two canisters with the same ID at the same time. But now, once you have this step, you can do an end-to-end migration completely. Yeah. Now, this I would like to demo that. The new command takes around 5 minutes to execute, so I'd like to start with the demo before I do a few more slides. So I'm going to use DFX to do a canister migration. So let me introduce you to my canister. This is, you might recognize it as the Hello World example. It is a normal canister on the internet computer, and this isn't a testnet or anything. It has a URL ending in ICP0.io. You can go to this website right now if you want. Right? It's a normal canister. It works. Hopefully, yeah. Yeah. So normal canister. You don't even know what subnet it's on. I mean, it's not very obvious. Just we can't tell from just looking at the website. The dashboard actually tells us it's on subnet NL6HN. So now I'd like to move it to a different subnet. And I'm just going to follow the runbook of the previous slide. So I'll start by creating a new canister. I'll be careful to specify what subnet I would like it to be on. This should only take a few seconds. This gives me a new canister ID, which in the end, of course, we won't care about, but I will need it for the purpose of the rest of my demo. Okay, now we want to transfer the state of the canister. I'll start by stopping both canisters. So now my canisters are stopped. So if you now go to the website that I showed earlier, you will get an error because it's a stopped canister. Next step, I'll create a snapshot of the old canister. That should also, like each of these commands, right, is a round trip to the IC and back, so like a second or so. Then I'll download that snapshot. Now, downloading the snapshot for my canister should be quite quick, but of course, canisters can have up to 500 gigabytes of state. If you want to download the snapshot of such a canister, of course, it will take longer. I'll upload that same snapshot back to the new canister. Uploading, I think, is a bit slower than downloading. Yep. So this gives me a snapshot ID that I need to keep. Nope. Apologies. The next step, I'll load that snapshot that I just uploaded. And I delete it again. We won't need it anymore. So what I've done now is I created a clone, right? I now have a new canister. It has a different canister ID, but it has the exact same state as before. At this point, I might also want to transfer cycles over or things like that, but I'm not going to do that during this demo. So now the only remaining step is I want to call migrate ID, which migrates the canister ID over. Now, it gives me a final warning to make sure I'm aware that my original canister will be deleted. Any data I haven't transferred over yet will be lost. But I'm, of course, okay with that. Now it should give me like a little progress bar very soon, unless I'm getting an error. But yeah, like this command now will take roughly 5 minutes to execute. So let me go back to, okay, so it has been accepted. So now the migration is in progress, but will take roughly 5 minutes. So let me go back to my slides and tell you a bit more about how it works. So canister ID migration, like I said, it takes around 5 minutes. We'll see if it'll be done before I'll get to my last slides or not. It also costs around 10 trillion cycles. So, I mean, this demo right now costs 10 trillion cycles. It's not cheap, but I mean, there are reasons why you might want to do a full migration with the ID and not just state. And the main reason is that if you do that, the canister from the outside will really look like nothing ever changed, right? You address it in the same way, it behaves in the same way. And that's particularly important if, for example, you have lots of other canister calling your canister, or maybe there are calls from outside the IC to your canister, and you cannot like easily change those calling sites. Another reason why preserving the ID might be very important is if your canister has a balance in some ledger, maybe it owns ICP. That is like, it's the canister ID that owns these ICP. Same if the canister owns Bitcoin or ECDSA keys, or if your canister owns neurons, all these things are linked to the canister ID. Now, in terms of like implementation, there were a few parts to it. There is, first of all, the core functionality, the act of migrating a canister ID, which we've implemented with a new NNS canister, which carefully coordinates the two subnets, the old one and the new one. And the main challenge there is you have to make sure that all the messages arrive at the right place, both during the migration as well as after the migration, because we do have some guarantees about messages and you cannot like violate those. But beyond the core functionality, there was also some performance work that was required. And that is mostly about routing tables. So the routing table is simply the mapping of which canister lives on which subnet. And the canister migrations feature kind of changes that in two fundamental ways. One is the routing table now changes potentially frequently. Previously, it was basically a static table. And the other one is it becomes more complex. And like this more complex routing tables kind of raises the question, what part of the protocols can handle that and which ones can't? Turns out mostly the protocol was fine handling that, but there were two places where we needed to improve performance. One is in the registry, which is the on-chain storage of the routing table, plus lots of more other things. There, it turned out to be a problem that the routing table can change a lot. And the other place where we needed to improve was around NNS delegations, which is a cryptographic proof that the correct subnet answered the call to the internet computer. There, it turned out the problem being that it meant that every call to the internet computer needed to prove that the right subnet answered, which it did by including the routing table, which led to which after a couple of migrations might lead to too much network load. So we needed to improve that. Now it's quite unfortunate that I have to go over these points so quickly. All of these are like technically quite interesting, and in fact they required a cross-team engineering effort. In general, the team working on this was across several teams and involved quite a lot of people. Again, because canisters and where they are is such a fundamental part of the protocol. So in terms of timeline, what we have right now is we've done a soft rollout of the functionality, which means it's not generally available, but there are some DFINITY internal principles that are allow listed to do migrations at the moment. I've used one of those principles for this demo. Also, the DFX command that I've shown is from a dev build, so that's your DFX version also won't have that quite yet. Next steps are to make it widely available, like remove this allow list and also get the DFX command to everybody, and also write guides on how to do an end-to-end migration. As you've seen from the demo, there's quite a few steps and you really want to follow a guide so that you don't forget anything. Medium terms, we have some ideas to make it more ergonomic, so hopefully at some point you won't need a guide anymore. And also there is the question of what you do about SNS canisters. For SNS canisters, it's particularly awkward that, first of all, you don't have access to it using DFX. And second, downloading a snapshot and then re-uploading it isn't really fully on chain. Long term, kind of the North Star of all of this work would be automatic load balancing. I mean, we are quite far from that, but canister migration is an important step towards it, as is subnet splitting, which is a related feature that you'll hear more about in an upcoming Global R&D. Okay, so that was my last slide. Let's maybe check it with my... Oh. Well, I got an error. Okay, so... Okay, that's a bit unfortunate. So I guess the migration didn't happen. But if I had gotten an error, the only thing left to do would have been to start the canister again. And it would basically be as if nothing ever happened, right? You can go to the same website, and the only thing that would change is that on the dashboard, you get a new canister ID, a new subnet ID. But yeah, that's it from me. Back to you, Dimitris.
I hope we were not just upgrading the subnet that your canister happened to be on, right? But yeah. Thanks, Stefan, for the demo and the update on canister migration. I think this is a very important feature, and yeah, I already saw some comments on chat that people were really happy to see it as well. So now we'll move on to Christopher with the demo on a Sui Wallet on ICP. So Christopher, please take it away.
Thank you. Yes, so the Sui Wallet on ICP, well, what is this about? This is a 5-minute chat about, I guess it's a flame war with a happy ending. And the TLDR of this small thing is chain fusion is really great. And threshold signatures make cool things possible. So this story started out with a flame war erupting on Twitter, with one of the founders of Sui saying, "Who the heck is building on ICP?" ? And I think Dom chimed in as well. Then some other person, posted this image that you see down to the left, saying Sui or ICP ? And then a big, the respective tribes were activated. And so some 100 comments later, there was a big old Twitter fight around what is the best chain. And I'm not really interested in this. No, I'm still interested in this more bigger perspective of decentralization versus centralization. So I'm like, we're all in this together. This pay attention to the big fight instead. It's the us all together, all chains against the old decentralized dysfunctional structures. So what if I were to build a Sui wallet on ICP, and not because it's hard, but because it's easy, and not to prove a point, but instead as an invitation to the Sui developer community, like instead of fighting us, let's you could build Sui applications on ICP. It actually works really well. So 8 hours later, I had created something that looks a bit like this, like a super basic wallet that derives an address for you. So you sign in using internet identity. It derives an address for you. It provides a receive page with a QR code and a send page. So let's see. I think I have a video. I don't want to demo it. It's just a 30-second video or something. So you press the receive button, copy the receive address there. I have two browsers here logged in, both in two different browser windows. Paste it into the other there and send some test tokens. And the transaction was confirmed. It's available on the Sui Block Explorer. And then wait for a few seconds and then reload and the transfer is done. So that was the demo. It's as simple as that. So maybe I won't even fill those 5 minutes. But let's move on to the next step here. And again, I did this to prove not to because it's hard rather than because it's easy. I'm a big believer in the threshold signatures. And after doing this, I realized I wouldn't have had to create the backend canister at all. So basically, I created a backend canister with two endpoints. One for getting the public key, and the public key then can be turned into a Sui address. So you see that to the left, it basically just does one call to the ECDSA public key function. And this, of course, since the key derivation is deterministic, you could do that in the front end completely. You don't even need to do a canister call. But I was too lazy to look up how that library worked. So I just went with this because I happen to be familiar with this call since before. And the same thing, then for the signature, you in the front end, I used the libraries provided by the Sui project to create a byte representation or hashed byte representation of the transaction that I then sent to the backend canister, of course, requiring the user to be signed in. And then it has to be hashed again, apparently. And then I signed that hash with the ECDSA threshold signature functions and return it to the front end, where it is actually sent to the Sui RPC directly from the front end, instead of, we could have done it with HTTPS out calls, but since the payload is signed and they have provide an open RPC endpoint, it's faster. It gives a better user experience actually doing it directly in the front end. So if someone in this call happens to be not familiar with threshold signatures, that is my last minute of this talk. Just quickly saying, a quick description about what it is about, that the nodes in an ICP subnet together can share or assign payloads. They each hold the key share per node, and the nodes collaborate to sign payloads, and the private key is never ever reconstructed, so none of the nodes have access to it, and it's a very resilient system. Up to 1/3 of the nodes can be offline and still produce a valid signature. So this is a great thing, the threshold signatures. It allows it to do ECDSA signing, EDDSA signing. We can support Ethereum transactions, Bitcoin transactions, Solana, and a whole host of other chains. So that was my short flame war with a happy ending, thanks to Sui Wallet. And the moral of the story, not moral of the story, it was that this thing was very well received, which was really fun to see loads of Sui developers actually being super positive about the possibility of building Sui applications on ICP.
All right. Yeah. Thank you. Oops, no, that's not what I wanted to share. Thank you, Christopher. Yeah, it's great to see that through collaboration and constructive, approach, we can get some really cool stuff to happen. All right. I think actually I'm not gonna share after all, and I'm gonna hand it over to Stan, who's gonna talk about the possibility of running something like SQL, like SQLite on ICP. So Stan, feel free to take it away and walk us through your project.
Okay, so my name is Stan, and today I'm going to talk to you about running SQLite on the internet computer. First of all, what is the problem? Now, how do we store data in canisters? In Rust canisters, it is usually the case, or often the case, that we use stable structures. This is something that allows you to preserve the information on the canister between upgrades. And one of those popular data structures, most popular, is the stable B-tree map. So it allows you to have a key value storage where you have some key, and then you can store with that key some value, and then you can retrieve that value later on, and it automatically finds it and works quite fast. So everything is nice. But one problem with that approach is your actions are basically limited to retrieving the value from by knowing some key, and then or maybe storing the value by the keys. And when we talk about databases, this is actually more than that. So you can actually have multiple multiple tables related to each other with integrity constraints. And there's this language called SQL, which most people probably know, that it allows you to have richer communication with the canister. So what is our goal is we want to have SQL on internet computer. That means one of the possibilities is to actually try to run the SQLite, and this is what we want to do. Now, why SQLite? This is actually a lightweight database that is designed for a single user, so there's no concurrency involved. Then it runs on millions of devices. It's very well tested, and actually it stores the database in a single file, which or maybe even memory. So you have a piece of memory, and then there's your SQLite database. And because of all of that, this SQLite as a library for the keeping the database is actually fits very well this ICP canister storage, because it's also a piece of memory that you use. Now, how we can do it? There was a previously known project, IC SQLite, but it has its own solution and limitations. But on my case, I've created this IC SQLite crate, which you can use in your Rust canister, and it's based on the popular SQLite library, which internally also uses this SQLite library. And then the workflow is as follows: that you use the VASI2IC tool to convert the compilation of the SQLite to something that you can run on internet computer. So basically, you have you have to first compile your SQLite to a VASI target, and then you use the workflow to convert it to a binary that you can deploy. And what you get in return is the VASI2IC is introducing. The IC SQLite dependency introduces the IC VASI polyfill library, which is also based on the stable structures. And what you get in return is you have all three types of memories available to you. So first of all, you have the SQL storage that you can use and use SQL to access your data. Then you have the standard stable structures that you can access pretty normally. And then you also are able to use the file system, because the IC VASI polyfill is internally using the stable FS. And you can just use your standard Rust functions to work with the canister with the file system. So it organizes a file system inside the canister, and you can use it as if it was on your local drive. Now, how do you add support to SQLite? It's very simple. You just add a dependency in your TOML file. So you say IC SQLite, then you and then there's one more thing you have to do. It is you have to update your DFX.json to actually use the VASI2IC workflow. I will click you, and then when that's ready, there's a special command which called with connection, and then you can use it to actually access your database. I can quickly demonstrate this to you. One moment. So here is a simple project. It was generated from DFX, the Hello World application, which I have changed a little bit. So here we have cargo TOML. I have added this IC SQLite dependency, and it has this feature called precompile. That means that it will not try to compile the SQLite, which is written in C, so you don't have to worry about that. But you can also have the option to actually compile the original source code of SQLite, and you can even have your own version of SQLite if you want to. But for simplicity, you just use this feature, and it should just work. Now, with DFX.json, you do a little change here. So you change the canister type to custom, and you add 2 build steps. First of all, you add the cargo build with a target of WASI. So here you say cargo build target WASI target, and then it produces this SQL backend file, and you have to convert it to make it runnable on the internet computer. And then you do that as a second command, and it should just work. So when you do these steps, you can just say DFX deploy, and it should just work. So for instance, we can try this out now. I'll try it with DFX. Okay, I have to start it. Okay, maybe like this. No, it's not. Okay, it's not giving me back my control. And then deploy. It was already compiled, so it should go fast now. And you can see, so it's compiling it. It's also running the WASI2 IC as an internal step. Then it actually deploys the canister. And then in the source code, you can see that we have some init function, some add function, and list. So init actually creates the database. Then you use this with connection, which checks if the database actually exists in the file system. It will create one if it doesn't exist, and it will connect to the existing one if it already exists. Then you can just normally use this connection to execute your queries. For instance, here you add a new person into a persons table, and you can use parameters, which is a nice way to insert data in your database. And finally, you can also return something. So for instance, here you create a connection, then you create a statement which will map. So the SQLite library will produce you the iterator that you can process. And then you can just iterate all of the elements that it has returned and collect them into a vector and return it to the end user. So this is a very simplistic approach. Here, I'm not using any data types. It's very simple. So I'm just returning a vector with some data. You can make it more nicely, but this is the simplest way you can do it. And we can now quickly check what we get in return. So if we find. So we have this add function. Let's say some name, then some data. Add. Maybe some other name. Emmy. Sales. Okay. And then it has accepted those arguments, and then I call a list. It just returns me a vector of the data that was returned. Now, once this is inside the database, it has stored everything, and even if I now decide to upgrade the canister, this data will not be lost. And of course, here with this command, you don't have to do anything special. It should just work. So with the next initialization, you don't need to have to do anything. You just call with connection, and it will just continue working with the existing database. Now let's return. So here, next slide. So some more tools were developed to work with this database. For instance, you can do a continuous development with the migration library provided by Christopher. So it means that you upgrade in your canister, it changes its internal structure, and your database might also get changes. That means that you want to upgrade your database as well. And this library helps you to do that. So it will automatically run those upgrade scripts, and your database will be up to date with the newest version of your software that you deploy. And there's also another small tool that I have developed. It's called IC Memory Link or ICML that you can also install. And it helps you to actually download your database from the canister in case you want to do something with it, say some heavyweight operations, or maybe you want to change this settings of the database, like change the page size. This is something that you would like to do locally on your computer instead of experimenting remotely and maybe risking of destroying your data. So this tool is available to you, and there are just two methods for uploading and downloading file that you have to implement. If you check it online, there's a small example how you can do it. It should be easier. And then you can also use this tool to download this database and maybe upload it into another canister. So it's another way of transporting your data from one canister to another. You don't have to download full canister if you don't want to. Actually, this tool also works with snapshots. So if you have your snapshot downloaded, you can also extract your database from that snapshot with this tool. Now, finally, I would like to, I did also some performance estimations with this database. I compared its performance with a stable tree map. And what I did, I created a data set with million elements in it and then added more elements to that set. And the outcome was as follows, that if you want to only insert a single element, then it works slower on the SQLite because it has a lot of more preparations, and it does journaling and so on, and maybe the parsing of your request. But then if you want to insert many new elements, SQLite actually scales quite well. So comparatively, say starting from 100 elements or maybe 1,000 elements, you will see that you can insert those elements faster than you would do that with the stable B-tree map. You can check the forum post about this, and if you want, you can also download the benchmark yourself and try it out. Now, there are some known limitations. I was experimenting with a larger database, and it was still possible to work with it. Say I created a 80 gigabyte database inside a canister, and requesting a data or adding new data was not a problem. However, with such a large database, you still have to be careful because, of course, this amount of memory you are not able to process inside your instructions. And if you have SQL request that actually scans the full table, you will always fail due to instruction limits. So when you expect the database to be large, you have to take care of creating all the necessary indexes and always avoid full table scans. That means that your select query should not actually try to list every element of the database, because it will always fail. You can also analyze your query to see if it's actually using full table scan and check. So if it's optimal, or if you know that your table will always be small, then you can use it. Even on a large database, some tables are small and some tables are large, for instance. So another thing that you can do with a large database is that you are able to stop early inside your request. So you have a function that checking the time. So for instance, you are iterating through elements, and then you decide, okay, now I don't have many instructions left in this call. Then you can stop early or quit early, and then maybe continue with the next call. This way, you can process large amounts of data if you need to. So that's it on my side, and I present again the links to the SQLite library, the migration, and the memory link for you to try out. That's it on my side, and thank you for your attention.
All right. Thank you, Stan. Right on time. I think there were some comments, questions, but I think they have been answered. So yeah, thanks everybody. That was all for today. I guess we'll see you next week, and until then, take care. Have a good day, good evening, and see you.